Hello everyone. Previously we had discussed on the suffix array construction along with the this one Casey's algorithm, right? So we saw that one completely. We discussed that one step by step, right? So now today we'll be discussing on the suffix automation algorithm, right? Also known as SAM, right? So here let's get into the definition part. So what does the definition part say here? A suffix automation, also known as SAM, is a powerful data structure that represents all the substrings of a given string efficiently. What it represents? It is a powerful data structure that represents all the substrings of a given string efficiently. It is the smallest deterministic finite automation that accepts all the suffixes of a string. Again, it is the smallest deterministic finite automation DFA that accepts all the suffixes of a string. Simple. Now let's come to the explanation part. Let's see this one step by step. Let's try to understand this one step by step. Same thing we'll be implementing in the algorithm or the coding part basically, right? First, let's imagine we want to know if a substring exists or not, right, inside the string, right? So naively or the straightforward approach would be we would check every substring, right? So that would lead to big of n square time complexity. So if you want to check whether substring exists and inside a string, namely we will check every substring quite obviously or straightforwardly. This is straightforward approach. So we'll check every substring. Then it would lead to big of n square time, right? What does the suffix automation do then? A suffix automation compresses all the substring into the graph-like structure with states and transitions. So this part is very important. So how it is different basically? So suffix automation compresses all the substrings into the graph-like structure with states and transitions, right? Each state, what it does, each state represents a set of substrings, also called as end positions, right? Each state, what it represents? It represents a set of substrings, right? Also called as end positions, right? So what does the SAM do here? String automation. It allows us to answer substring queries, longest common substring problems, and the substring counting and big O of n time after building it. Again, SAM allows us to answer substring queries, longest common substring problems, and the substring counting and big of n time after building it, right? So this is main thing, right? Big of n time. So construction uses clever trick of maintaining the last pointer and link between the states, ensuring we only add what is necessary. This we will be seeing within the code, man. Don't worry about it. So let's follow the same thing step by step within the code or the algorithm. Let's start writing the code. Let's get into the algorithm part or the coding part, right? So first let me go with class state here, right? So this one, let me go with state. So within this one, let me go with the method initialization part, right? Constructor part basically. So this one, let me remove and let me go with the let's go with the transitions first. So this one will be self.next. This is fine. And after transitions, let's go with the suffix link as well. So this one will be self.link. Let me assign this one to the -1, right? So the next one is maximum length of the substring for the particular state or for this state. So we can just go with self.length. So let me go with let me initialize this one with 0. This is fine. So now let me initialize one. let's go with one more class here. Class. So this is suffix automation class, main class. So I'll just go with suffix automation itself, or I would have written the same. This is fine, man. Suffix automation. This is fine. Now within this class, what shall we do? Let me go with again this one, initialization part, right? So I'll just go with def init. So let me remove this one. This one will be self.states. This is fine. This one will be state. Yeah. self dot last, so this one equivalent to 0. So state 0, this one initial, state 0 will be initial according to line number 28, and the line number 29 we have added the last state, right? So this is nothing but the last added state. This is fine. Now let's go with the extended method. So what we need to extend here, we have to create the new state, and we have to set the transition from the last, and we have to set the this one, what do we call, suffix and suffix link. Basically these three things we need to do. First let me create the method or the function extend first. So this one will be extend. Let me go with self comma this one C. Now within this function, first we have to create the new state, right? So I'll just go with current equals length of self dot, let me go with states or state, yeah, states itself, right? So I have given states itself. Let me go with self dot states. Let me assign this one, sorry, we have to append this one, right? Add or append, we have to append the state basically with a parenthesis. So this is fine. Next let me go with self dot states here current, so this one dot length equals, let me assign this one to self dot again states, this one self dot last length plus 1, right? So this is fine. This is the first step. We have successfully created the new state. After successfully creating the new state, what we need to do, we have to set the transition from the last, meaning here let me assign this one p to self dot last. This is fine. Now let me go with the while loop here. So this one p not equal to 1, sorry, this will be not equal to -1, and c not in self dot states p dot next here. This is fine. Within the while loop, let me go with self dot states p dot next of c, this one equivalent to current. This is also fine. P equals self dot states p dot link. So this is fine. Now we are done with the step 2. We have set the transitions from the last, so that's what we did. So finally we are left with only one step. So this is going to be huge. Basically we have to set the suffix link as well. So let's go with the simple if condition first. If p equals -1, we are setting the suffix link, right? So within the if condition, what we need to do, I'll just go with self dot states here. So this one current dot link here, this one let me assign this one to the 0, else not elif, else, so we have to set the queue to self dot states here of p next to the next, right? Next within the array we have to pass c, right? So if, again let me write the if condition here. If, so this one will be indentation problem, we have to start from here itself, right? So this one has to be if self dot states of p dot length, so this one plus 1, it is equal to self dot states q dot length. This is also fine. Then self dot states, so this one again let's pass current here dot link. So this one, let's assign this one to the queue, right? So this is fine. Else what we need to do, else we have to clone, right? So let me go with clone here. So let me assign this one to the length of we have to pass self states basically, right? Self dot states. So this is fine. Again we have to append the state, the same thing. Where I have made use of the append here, this one, let me copy the same thing here, self dot states dot append. So this is fine. Now the next thing is we have to go with the cloning part, right? So this will be again self dot states of clone. So let me go with length here. Let me assign this one to the self dot states. So let me pass p here dot length plus 1. This is fine. Again self dot states. So this one will be clone dot next. This one, let me go with self dot states of queue dot next dot copy. This is fine. We are left with same thing, self dot states here. So again let me go with clone. This is fine. This time we have to go with the link here. This one will be self dot states. So we have to pass queue this time. Dot a linking queue, right? So we have to pass link. This is fine, man. Now let's go with the while loop. Sorry, let's go with the while loop, meaning while p not this one not equal to -1, right? So I'll just go with while p not equal to -1 and self dot states this one of p dot next of c. If it is equivalent to q, then I'll just go with self states of p. This is fine. Dot next c. This one equivalent to clone. It's fine. p equals self dot states. So we have to pass p this time. P dot link basically. Fine. We are left with only two things. One is we have to go with states of q dot link here. This one we have to assign this one to states dot current dot link, current basically, right? States current dot link, right? So this one is equivalent to the clone basically, right? So this is fine. We are done with almost all the things, except we have to this one assign the last to current finally, right? So this one, just give me a second here. Yep. Let me go with self here dot last equals current, right? So we are done with the algo basically. So this part is basically nothing but what do we call, we are just setting the transition from the last, right? So we have successfully we are setting the suffix link basically. We have successfully set the suffix link, right? So from here basically, where did this go? Yeah, from here, not this one, line number 41, p equals -1. We are setting the prefix, this one suffix link, right? So this one was the step 2 basically. P equals self dot list whatever I have given this part. So basically we are setting the transitions from the last here. So step 3 is this one, if p equals -1 whatever I have given. So we have set the suffix link here, and the first part would be creating the new state, right? So creating the new state within that extent this one line number 32 basically. So this one we are just creating the new state, right? So this is initialization part, these two, this is fine. Now we are done with the coding part, right, or the algorithmic part. So let's do one thing, let's build the suffix automation for the string. So let's see the example case man here in simple terms, right? So I'll just come here, so I'll just give, let me consider some string here. I'll just go with a random string AB, or yeah, let's go with the BA or AB, anything that works. So I'll just go with the suffix automation SAM. So let me pass suffix automation here, this one itself. This is fine. We have to give parenthesis as well, right? For ch n s. So let me go with sam dot extend. So let me pass ch here. This is fine. This is fine, man. Now let's do one thing. Let's show the output. I'm meaning so let's show the states and the links basically within the output. So let me go with for I comma st and enumerate. So let me go with suffix automation dot states. So this is fine. So let me print f followed by this one, what do we call, we are making use of the string interpolation here, state. So this one is nothing but I. This is fine. Next let me pass length equals st dot length. This is fine. Link. So this one has to be st dot link, right? So this one has to be st dot link. Finally let's go with the transitions as well. Transitions. So let me pass here st. It's not showing, right? So I'll just go with the next, right? So next is the next. So this is it for the what do we call, example usage. So the output that we need to get here is state 0 to state 10, right? So state 0, length is 0, link is -1, we have to get transitions 1, a equals 1, b equals 3. Same thing goes from the state 1 to state 10. State 1 length will be 1, for the state 2 length will be 2, state 3 length 1, state 4 length 2, state 5 length 3, state 6 length 3, state 7 length 4, state 8 length 4, state 9 length 5, and state 10 length 5. So this one we need to get, and the transitions for the first one we have 2, A1 and B3, and for this one from 1 to 8 we have only for the B, right? So transition for the state 1 B2, right? For the state 2 A5, for the state 3 A4, for the state 4 B6, for the state 5 B7, for the state 6 it is A8, for the state 7 it is A9, and for the state 8 it is B10, right? So finally for this one state 9 and 10 we have we don't have any transition, so we'll be leaving that one to the empty, right? So we have to get this output. Let's check whether we get the correct output or not, right? So this is it for the algorithm basically, right? So we have followed the same thing, this one explanation part, whatever I have explained, we went step by step here. So let's try to run the code. Let me give Control J here. Let me copy the file name. So here let me type Python Control V dot py. Let me run this one, man. Yeah. So we are getting only until 5. What's wrong here? So basically 2 5 4 we have to get here. 5 4 6 7 this one we have to get, right? From 0 to 10 we have to get. So somewhere I have missed something within the code basically, right? So just give me a second here. So here I have just changed some code here within this one. We are just redirecting current as well here, right? So that was the wrong thing basically, right? Also I have changed this one spelling here. This is not the whole time I have called this one suffix, this one automation, not the automation, basically automaton, right? So this one is suffix automaton algo, right? So not the automation basically. Don't get confused with this. So now let me try running this basically. Let's see whether this works or not, man. So yeah, now this is working. 0 1 2 3 4 5 0 1 2 3 4 5. This one actually states we have to get 6 7 8 9 10, right? So accordingly, so this one, oh, this is still I'm confused, man. State 0 1 2 3 4 5 states we are considering. Still this is fine. If this part works correctly, this is fine. Length 1 2 3 4 5, yeah, length 1 2 3 4 5, right? So this one 0 twice, 1 yeah, 0 has to get only print once. Other things has to print twice actually. 1 1 2 2 3 3 4 4 5 5 basically, but 0 is also printing twice. Just give me a second here. So this is fine, man. This works correctly itself. This is fine. This one is getting extra printed. This is fine. Now accordingly with the code that we have written, this is fine. So the output that we need getting here is A1 B2. So this one B2, A3 B4. So this one is fine. Yeah, this is fine. A5 B2, this one A3. So here also instead of B we have to get A here, A4 actually, right? For the state 3 actually, right? State 3 with the length 3 we have to get A4 actually, not the B, right? So that is one thing. So we have given AB, this one here, ABA, this one BA. So what is the wrong thing have done? I don't know, just give me a second. So this is fine. Let me do one thing. Let me keep the same code. So currently the clone is not working. I don't know clone is not, why clone isn't working. The code is correct actually accordingly, but we have to get the 11 transitions basically. We are getting only 6 transitions here, 0 to 5. So other 5 transitions we are not getting. I don't know why, but here whatever the clone, this one we have written here, right? So this one also had mentioned, right? So somewhere, just give me a second here. This one, this is correct actually, but we are getting the wrong output actually. 11 this one transitions we need to get, 11 states we need to get here, 0 to 10 basically, right? So 11 transitions, so this is fine. So the same thing again we have to get actually 1 2 3 4 5 1 2 3 4 5, right? So for this one AB ABA, the suffix automaton basically, so this one has to be 11 transition. The same thing has to come here. The clone part is not working, right? So I just wanted to say this. This is fine. Now again, so let me explain the output now. State 0 here, this one, the first one basically. So this is the initial state, links nowhere, right? So links nowhere in the sense it will be -1 basically. Transition start with A and B. Transition start with A and B. See here we have ABA BA, right? So transition starts with A and B. State 1 we will be going with a substring A that links back to the state 0. This is fine. State 2 we are going with a substring AB that links to state 3, right? So which also represents B. State 5 we will be going with a substring ABA that is linked to the BA state, right? Finally we are going with final states, this one 9 and 10. This is same version of this one 4 and 5. So state 6 7 8 9 10 we have to get same thing from this one state 1 to state 5 basically, right? So final states like 9 and 10 which represents the longest substring AB ABA and BABA, right? So basically the structure compactly stores all the substrings, right? So within the suffix automaton. So in this way it is very helpful basically. Here again I'm telling, So we are getting the transitions from 0 to 5. Other 5 transitions we are not getting, or other 5 states we are not getting here, right? So the code I checked, so this is basically correct. I don't know why this is not working, so I can just try to run it. I'll just be uploading this one. Just tell me whether this works on your machine, basically, right? So this is fine. Now we're done with the suffix automaton algorithm, right? So now let me summarize whatever we have learned so far. Suffix automaton is equivalent to the compact automaton for all the substrings of a string. Just keep this one thing in the mind. So this is very important. Again, suffix automaton is equivalent to the compact automaton for all the substrings of a string, and this will be built on big of n time and space, right, as we had discussed earlier within the definition part. So this is useful for the substring search. Basically it is useful for the substring search itself. So we will be making use of the suffix automaton algorithm for the substring search itself, right? For counting distinct substrings, longest common substrings also this is used. Mainly it is used for the substring search. Just keep this in mind, right? So example that we considered with ABA, right? So this shows the state links and transitions that is capturing every substring efficiently, right? So this is fine. Keep the first two things in mind, first three things in mind. So suffix automaton is equivalent to the compact automaton for all the substrings of a string, built in big of n time, so end space. So this is very important, and it is useful for the substring search. As I've said, this is very helpful in the substring search, right, and counting distinct substrings as well as the longest common substrings as well. Mainly it is used for the substring search, right? So this is fine. Now we are done with the this one, suffix automaton algorithm, right? So this is one of the important algorithms as well, string algorithms. So next we will be discussing AHO Korasek algorithm, right? So AHO Korasek algorithm, also known as the multiple this one, Korasek multiple pattern matching algorithm, right? So next we'll be discussing on the topic AHO Korasek algorithm, right? So for now this is it. Thanks for watching, guys.